know the devastating effects of thermal cycling on buildings. When considering the integrity of buildings and infrastructure, thermal cycling emerges as a silent yet formidable adversary. This phenomenon, characterized by repeated heating and cooling cycles, inflicts substantial thermal stress on materials, leading to their rapid degradation, breakdown, and eventual failure. Understanding the mechanics of thermal cycling and implementing strategies to mitigate its effects is crucial for preserving the longevity of our built environment, especially in the face of escalating climate change. In this episode, I spotlight the understanding of thermal cycling and its potentially damaging effects. Thermal cycling involves subjecting materials to fluctuating temperatures that swing between extremes. This process induces expansion and contraction in materials, creating stresses that can lead to cracks, delamination, and other forms of damage. Over time, these stresses accumulate, weakening the structural integrity of buildings and surfaces. Whether it's the sweltering heat of summer days followed by the coolness of the night, or the seasonal transitions from harsh winters to mild springs, the relentless cycle of temperature changes wreaks havoc on construction materials. Impact on building materials. Concrete, metal, wood, roofing, and composite materials all respond differently to thermal cycling, but none are immune to its effects. Concrete may develop microcracks that, with repeated cycles, propagate and widen, compromising the strength and durability of the structure. Metals, depending on their composition, might experience fatigue and brittleness, leading to fractures. Wood can warp, split, and lose its structural cohesion. Even advanced composites, touted for their strength and resilience, are not entirely resistant to the insidious damage caused by thermal cycling. Consequences of ignoring thermal cycling. The repercussions of neglecting thermal cycling can be severe. Buildings and infrastructure that fail prematurely due to thermal stress not only incur substantial repair and maintenance costs, but also pose safety risks. Structural failures can lead to catastrophic collapses, endangering lives and disrupting communities. Moreover, the environmental cost of replacing damaged materials contributes to increased carbon footprints, exacerbating climate change. Eco-friendly solutions, green coatings, and sustainable materials. To counteract the damaging effects of thermal cycling, the construction industry must embrace the new opportunity with eco-friendly products and sustainable practices. The right green coatings, designed to protect and defend surfaces against extreme temperature variations, offer a viable solution. These coatings are formulated to enhance the durability and resilience of building materials, providing a protective barrier that mitigates thermal stress for the long term. Benefits of the right green coatings. The right green coatings not only safeguard materials from thermal cycling, but also offer additional environmental benefits. Many of these coatings are made from non-toxic, renewable resources, reducing the reliance on harmful chemicals. They often feature high reflectivity, which can minimize heat absorption, leading to cooler building surfaces and reduced urban heat island effects. Furthermore, by extending the lifespan of building materials, the right green coatings decrease the frequency of repairs and replacements, stopping the unnecessary generation, transportation, and storage of unwanted waste, which in turn conserves resources and lowers overall environmental impact. Connecting green solutions to climate change. Adopting the right green coatings and sustainable building practices aligns seamlessly with broader efforts to combat climate change. Buildings account for a significant portion of global greenhouse gas emissions, primarily through energy consumption for heating, cooling, and maintenance. By enhancing the durability of materials and reducing the need for frequent repairs, the right green coatings contribute to more energy-efficient buildings. This in turn lowers the demand for energy production, often sourced from fossil fuels, thereby reducing carbon emissions. Moreover, the use of eco-friendly products supports the shift towards a circular economy, where materials are reused, recycled, restored, and maintained for longer periods. This reduces waste, conserves natural resources, and promotes a more sustainable construction industry. To sum it up, thermal cycling poses a significant threat to the durability and safety of buildings and infrastructure. However, through the adoption of the right green coatings and eco-friendly materials, we can mitigate its damaging effects and contribute to a more sustainable future. These solutions not only protect our built environment, but also play a crucial role in addressing the challenges of climate change. By integrating innovative, sustainable practices into construction, we pave the way for resilient, long-lasting buildings that harmonize with our environmental goals. You may like this quote from Mari Copani, youth activist. It's time to shift from being consumers to being caretakers. We have the power to shape a sustainable world through our choices. What are your questions about this episode? We are always here to help and excited to answer them. Thank you for listening, and see you on my next episode.